Hey guys, welcome back. This is Jonathan Gardner. Today we're covering section 1.2 of Basic Mathematics by Serge Lang. This is rules for addition. And before we go much further into this subject, I wanted to point out to you a couple things. Number one, did you notice how this first section was kind of strange? It's not quite like the textbooks that you learned in your junior high or high school. This is because he's presenting the material in a way that'll help you develop the foundation to really understand how proofs work. And this is going to be no different. We're going to learn a bunch of rules, and we're going to use those rules to do amazing things with numbers. And we're not focused so much on how to add as what the process of addition looks and how you can manipulate that to solve equations. So the first thing we're going to learn about is commutativity. C-O-M-M-U-T-A-T-I-V-I-T-Y. Commutativity is the property of addition, and its multiplication as well, where it doesn't matter what order you add in. So you can add A and B this direction, or you can do it this direction. Let's draw a box around that because you have to memorize that equation. Well, you won't have to memorize so much as know how it works. This just basically says that you can add numbers. If you're adding like 1 and 2, for instance, you can do 1 plus 2 or 2 plus 1, same thing. And the example he gives in the book is with 3 and 5. So if you take 3 plus 5, that's going to give you 8, obviously. But you can do 5 plus 3 as well, and that also gives you 8. The next property of addition that we're going to look at, we're going to use quite a bit, is called associativity. A-S-S-O-C-I-A-T-I-V-I-T-Y. Double check I got the spelling right. Yes, I did. Associativity has to do with when you have 3 quantities that you're adding together. The question is, do you add the first 2 first or the second 2 first? And the answer is it doesn't matter. So associativity says that if you take A and B and then add them first and then add quantity C later, it's the same as adding A to B plus C added first. Let's draw a box around this. So the example he gives in the book, he has 3 numbers that he's 3 and 5 and 9. So you can say 3 plus 5, do that first, plus 9 is the same as 3 plus 5 and 9, right? So 3 plus 5 is 8, so 8 plus 9 should be equal to 3 plus 5 plus 9 is 14. And sure enough, this is 17, and that's 17, so it works for 3, 5, and 9, and it works for any integer. Now, because of this property, we oftentimes, in fact, we almost always, reduce this form into this simple form. We just write A plus B plus C. And that means you can add A plus B first, or you can add B plus C first. Now, keep in mind, associativity and commutativity, this works for integers. Positive, negative, 0, doesn't matter. It's not going to work for all the different types of numbers you're going to learn about. When we get to matrices and we are multiplying matrices, it's not going to quite be the same. So just remind yourself that it's important, and it's not universal for all types of numbers that you might encounter in mathematics. Let's talk about negative numbers, how that works. So the issue he has is, suppose you had negative 2 plus 5, and you add 4 more. Well, what's negative 2 plus 5? Well, we reminded ourselves it doesn't matter the order we do this in. So negative 2 plus 5 is the same as 5 minus 2. I think we're going to cover, yes, we're going to cover that very, very next. This is just basically 5 take away 2, so you get 3. Add 4 more, what do you get? So we get 3 plus 4, which is 7, right? Now we could do it the other way too. We could start with negative 2, and then we can add 5 and 4 together first. That's going to get us negative 2 plus 9. And we can rewrite this using commutativity as 9 plus minus 2, right? And that's just going to give you 7 as well. So sure enough, it works for these numbers too, even if they're negative. Let's do a little bit more complicated one. Let's scroll up the paper all the way to the bottom there. And we're going to start with 2. We are going to add negative 5. And then we're going to add negative 3. Okay, so 2 plus negative 5 plus negative 3. In the first case, we'll add the first 2 first. In the second case, we'll add the second 2 first. So 2 plus negative 5. Well, that's going to give you negative 3. I'll talk about why in a second. And then we're going to add negative 3 more. And -5 plus -3, that's going to be -8. And we're going to start with 2. And in this case, -3 plus -3 is going to give you -6. And 2 plus -8 is going to give you -6 as well. So it checks out when you use negative numbers as well. Hopefully you're not surprised by any of this. Next, let's look at what he calls equation N3. Let's scroll this down. Try to keep the table from showing so we can maximize the real estate here. N3 states if A plus B is equal to 0, then A must be equal to minus B and B must be equal to minus A. That's what equation N3 says. Let's go ahead and draw a box around that. Try to do that neatly. I have the microphone on my face. I dropped the lapel mic. It gives a really deep tone. I didn't like it too much. And I went with the condenser mic that I have, the USB condenser mic, the Samsung that I really like. Okay, so what does this mean? Well, if you add two numbers together and they equal 0, then that must mean that they are the additive inverses of each other. Meaning when you add them to each other, you're going to get 0. And we say minus B. We don't say negative B because B could be negative to begin with, in which case minus B would be positive. So it's not negative B, it's minus B. All right, so to prove this relationship, he says let's start with A plus B equals 0. And let's add negative A to both sides. So we're going to write minus A plus B equals 0 minus A. Well, he puts it first, but plus minus A. Okay. And why are we allowed to add minus A to both sides? The reason why we're allowed to do that and get away with it is because we have this equality sign here, right? And we can do whatever we want to one side as long as we balance it out with what we do to the other side. We can multiply both sides, we can add to both sides, we can do some other things too that you'll discover later on. All right, so A plus minus A, or minus A plus A, we know that's equal to 0. And then we have a B. And 0 plus B is just going to give you B. Okay, let's drop this equal sign down. And 0 plus minus A, that's just going to give you minus A. Okay, so there we go. We've just proved that B equals minus A when A plus B equals 0. And we can use similar reasoning. If we add minus B to both sides, we'll recover that A is equal to minus B. So I'm going to leave you to do that on your own. You don't need my help to do that, hopefully. The other thing that he notes at the bottom of this section, he kind of hides this, but it's important. He says that A minus B means the same thing as A plus minus B. That might be unfamiliar to you, but it's something you'll have to get used to. All right, moving right along. I should mention there's a homework assignment, and I want you to do the homework assignment, so try to follow along. I will give you hints on how to do the homework. It's not trivial. It's not like the homework you're used to doing. Okay, so the conclusion here. Let's take a new piece of paper, and let's draw down some conclusions here. Adjust the paper. There we go. All right. Conclusion. Okay, because of commutativity and associativity, we can rearrange terms. Let's write that as a G actually instead of that weird S shape, however we like. And this is the important bit. This is what commutativity and associativity gives you in algebra. All right, so let's walk through the example he gives. I'll use my little blue marker here with a fine point. So we have A minus B plus C. And we're going to manipulate that using the definition for what A minus B means. So this becomes A plus minus B plus C. Okay. And I'm going to highlight here one of these colors. Let me grab another marker. Here we go, hot pink. I like pink. Pink is a fun color. Yes, this is sharp. So we're going to take these parentheses here, and we're going to move them using the associativity rule. Let me pull up for you what that looks like. Remember the associativity rule? We're able to move parentheses among terms. So these parentheses moved from here to here. And so let's do that here. So we're going to move these pink parentheses from there to over here. Okay, but let's be careful. So we're going to start with, let's put an equal sign, let's drop the equal sign down, a plus, and the first term is minus b, and the next term is c inside the pink parentheses there. That's what we're able to do. We're able to move the parentheses thanks to associativity. Okay. Now if we did commutativity on the inside of that parentheses there, we can write a plus c and minus b. So I'm going to skip a step and jump from c plus minus b just to straight to c minus b. Okay. And the last thing that he does is he uses associativity one more time, and he moves the parentheses to the left. And what we've done here is in every one of these cases, let me grab a nice green marker. Hopefully this, no, green's not going to show up well, is it? Let's do a purple. Let's do a purple. Okay. I guess this is a maroon, right? If you look, do you see how the A, every time you have these, you have an A, you have a minus B, and you have a C. So there's our A, and there's our A. There's our minus B's, and there's our C's. So we preserved a number of terms. We just moved things around. In the end, we had the A here, the minus B went to the end, and the C was in the middle. And for this reason, we don't use parentheses too often. We just write it out like this. We would just write this formula out as A minus B plus C. Or, we can choose another term. We can start with minus B, add the A, add the C. Or we can start with C minus B plus A. Doesn't matter. We can arrange those however we like, thanks to associativity and commutativity. All right. Let's move right along to equation N4. So N4 states, it says A is equal to minus A. All right. The reason why this is true is if you go back to N3, let's go over here, go back to N3, we're going to say, what about when A plus minus A is equal to 0? Well, that means A must be equal to minus A. You see? So A is equal to minus A, because when you add the additive inverses, you get 0. Okay. What happens when you have 3? What if you had minus A? What will that give you? Well, 2 of them will give you positive A, so that's the same as minus A, so it's just minus A. That's all it is. What happens if you have 4? Well, that's minus positive A, which is equal to A. You see how that works? If general rule, you can probably figure this out on your own. If there's an odd number of minus signs, it's minus, and if there's an even number of minus signs, it's plus, or it's positive. It's not minus. It's either minus or not minus. All right. Moving right along, we're going to do distribution of the minus sign. Equation N5. I'll get a new piece of paper for that. Paper's cheap. Your attention is not. So let's go N5. N3, N4, N5. N5 says that if you have minus A plus B, that's the same as minus A minus B. Okay, what is that doing? Basically, when you're adding two terms together, the minus sign will be shared among each term. We're going to see in multiplication that isn't the case, but for addition it is. Okay, and because it's equality, you can go backwards as well. So you can factor out the minus sign. If you have two terms that are both minus, you can factor out the minus sign and then have two terms that are added together inside parentheses. All right, let's do some proof. So I'll just draw a box around this. It's really just one equation, just written two different ways. All right, let's do the proof. So if two numbers are integers, in this case in the book he uses x and y, if two numbers are integers and x equals minus y, right, then that means x plus y has to equal 0. That's from equation N3. Right? All we have to do really then to show, if we're going to show that this is equal to that, all we have to do is show that a plus b plus minus a minus b is equal to 0. Because if we can turn this one negative, and I'm sorry, minus, then we'll get that, and then we'll have this on the other side. Okay. In order to do that, we're going to take these terms and start rearranging them. So we're going to take the a and move it here. The minus a, we're going to move it here. Then we're going to take the b and the minus b. A minus a is 0. B minus b is 0. And 0 plus 0, of course, is 0. So we've just proved this using some simple algebra. Okay. As examples, let's write down some examples here. Oh, there's a lot of room on this page. As examples, we have minus 3 plus 5. Is that the same as minus 3 minus 5? Well, that's minus 8. And if you start at minus 3 and move left 5, then you'll get to minus 8 on the number line. So this is indeed equal. So that checks. Okay. And what if we had minus 4 plus 5? Is that the same as minus 4 minus 5, which is 4 minus 5? Well, this one, let's see, 5, then move left 4, or start at negative 4 and move right 5, you're going to get 1. This one turns into, oh, let's jump all the way over here, 4 minus 5. So you start at 4, move left 5, you're going to end up at negative 1. So that checks out as well. Pretty straightforward stuff. I don't really see a reason to do the other. Let's do one more. So minus 3 minus 7 should be equal to minus 3 minus 7. Okay. So this is minus 4 should be equal to minus 3 plus, plus 7. Right? And I ran out of room, but the answer here, 7, you go left 3, that's just 4. I used commutativity to move them around, and then minus 4 is indeed equal to positive 4. So that works. Everything works. Everybody's happy. Memorize this equation. That's distributing minus signs. The next rule that he wants you to consider is something that he says is so natural that you probably don't even think you want to consider it. Probably not much point to considering it. It says if a and b are integers, positive integers, then a plus b is also positive. Okay, so if a and b are positive integers, then a plus b is also positive. Okay, we're not going to try to prove this. We're just going to assume it's true. Okay, when I say that word assume, it means we're going to pretend it's true, whether or not it's true. We're not going to try to prove it's true. We're just going to say it's true and move on with our lives. So if that's true, then what about if a and b are negative? Can we show that a plus b is also negative? So let's write down the statement. Let's see if we can show that. The proof is rather simple. Okay. So the proof works like this. Consider a is equal to minus n, where n is positive. And then excuse me, b is equal to minus m, where m is positive. Then a plus b is equal to minus n minus m, which is equal to minus n plus m. And n plus m is positive. So a plus b is negative minus a positive integer. See? Pretty simple proof, isn't it? Okay. All right, before we get to the homework exercises, there's one more section to consider. I would consider this like the most important thing. This is what we do all day long when we're using addition in algebra and solving complicated physics equations. And trust me, you'll be doing this all throughout your physics career. You'll be doing it in quantum mechanics and electrodynamics and everything else, okay? The way it works is this. So consider you have a plus b equal to c. These are all integers, of course. Okay. What we can do is we can add minus b to both sides. Let's draw out what that looks like. So we have a plus b minus b equals c minus b. And we end up with a is equal to c minus b. Because b minus b is 0, and a plus 0 is just a. Okay. If we added minus a to both sides, and I'll do it on the left here, minus a plus c, then we're going to get b is equal to c minus a. And I used commutativity to just switch the order there. Okay. All right. And let's look at what this does. So we start with a plus b equals c. And it can go one of two directions. A equals c minus b, or b equals c minus a. And these two can go that direction. You can go back and forth in some sort of triangle. Okay. And a better way to look at this is to consider a plus b equals c. And then as we move b across the equal sign, right, that means we have to flip its sign. So this becomes a equals c minus b. That's what happens when you move terms. When you're adding terms together and you're moving a term across the equal sign, you have to flip its sign. All right? Let's do a couple examples on this, because this is pretty critical. So let's do some examples. So let's say we're trying to solve for x. We have the equation x plus 3 that you can't, you can't see it, excellent, equals 5. Well, let's take the 3, let's move it to the other side. So we have to flip its sign. So we have x left over on one side, then we have 5 minus 3 equals 2. X equals 2. And if we plug in 2 up here, let's go ahead and just plug it in. This is a different color. So we have 2 plus 3 equals 5, which indeed is correct. So 2 is the correct answer. We just checked our work. Another example. Let's say 4 minus a equals 3. Well, in this case, the a is minus. I'd like to have the a turned to positive. One way you can turn the a positive is you can flip its sign by moving it across the equal sign, and we'd like to move this 3 over this direction as well. So it's going to flip its sign as well. So we have 4 minus 3 equals a. So a equals equal to 1. Or we can write it this way, either way. And let's plug that in, see what happens if we were to start with 4 and subtract 1. Would we get 3? Absolutely. So it checks out. Good. That's the solution as well. Last one. This one's a little bit confusing. We start with minus 2. We subtract y, and we get 5. What is y? Well, same deal. Let's move the 5 this way. Let's move the y this way. And to confuse you further, I'm going to flip it all around. So I'll just write down y equals minus 5 minus 2. So I'm probably confusing you really hard. Let me tell you what I did. First of all, the y moved across the equal sign, and then I flipped equals. So 2 moved across. It didn't move across, but it did flip. The 5 moved across, and then it flipped as well. Okay. Is that confusing enough for you? Let me show you the in-between steps, but you should be able to do this in your head. So the in-between steps. So we start with, let me use a blue marker to kind of show this off to the side, because I will be doing this all the time from now on. And so you have to be aware of how it works. All right. So we have minus 2 minus y equals 5. We move the y to the other side. Minus 2 equals 5 plus y. We move the 5 across. Minus 2 minus 5 equals y. Then we flip the two sides. Y equals minus 2 minus 5. And then finally we reverse the order here using commutativity. So y equals minus 5 minus 2. That's what I did. All right. You might have to watch that a couple times to fully pick up on what's going on. Lastly, y equals minus 5 minus 2, that's minus 7. And if we plug that in, minus 7 here, so minus 2 minus minus 7, so add 7. So we start at minus 2, we go right 7, we end up at 5. All right. All right, if you missed it, this is how you do addition with positives and negatives. So if they're both positive, you just add. So 5 plus 3, you just add it together, it's 8. If they're both negative, you add the positive and take the negative. Okay? So you would take, so minus 5 minus 3 would equal minus 5 plus 3, like we saw, which is just minus 8. You see? So you take the positive version of the negatives, you add them together, you take the negatives of the whole thing. You're still adding in the end. Okay, so that's 1, 2. Third case, if they're different, take big minus small and keep the sign of the big. So if we had minus 5 plus 3, we would take 5 minus 3 because 5 is bigger, and we'd use negative. So negative 5 minus 3. If it was the other way around, you had plus 5 minus 3, right? Then it'd be positive because the 5 is positive, and you go 5 minus 3. You see how that works? So in this case, it's going to be negative 2. In this case, it's going to be positive 2. You guys know how to do this already. This is the one that'll confuse you. You just have to remember it's the same, you just have to reverse the sign. So that's how you add the numbers. All right, finally, I wanted to go over the homework problems, give you some hints on how to solve these. So problems 1 through 13. These take the form, they say, okay, justify each step. So you have a plus b plus c plus d, this is number 1, is equal to a plus d plus b plus c. And how in the heck are you supposed to do that? Well, there's 2 or 3 approaches you can take. One approach is you just write it down like this. A plus b plus c plus d. Then you move the terms around however you want, and you end up with what you get. And that's the easy way to do it, and that's how we do it. I encourage you to do it the hard way. The hard way would be you apply associativity and commutativity. For instance, you can take this, you can start with a plus b plus c plus d and go to b plus a plus c plus d. And that's terrible. There's 2 pluses there. Okay? You're switching a and b. And then you'd write justification, you'd say that's commutativity. Right? And then if you wanted to move parentheses, you have to pay close attention. Right? This is the parentheses in green, and then we have the parentheses I'm going to mark in red. Sorry that my line isn't clear. This is what you do. So this c plus d is a single quantity. It's a number. Okay? You can call it x, you can call it y, whatever you want to do. So when you move parentheses, b plus the green parenthesis, a plus this whole thing, c plus d. You see? And then inside here, you can further move this inside parenthesis, so you get b plus a plus c plus d. Okay, and this would be associativity. This would be associativity. And you keep doing these kind of manipulations using commutativity and associativity until you get the result you want. All right, that's how you do exercises 1 through 13. This will be a fun exercise for you, especially it'll get your mind geared up thinking of proofs. There's more than one way to skin a cat in these kind of problems. Problems number 14 through 21, basically you're solving for x using that last part that I told you about. Let me pull up the sheet here to remind you what that looks like. Here we go. Here's some examples from the book, how to solve, remember this sheet. And of course, then you have this little thing that I showed you, basically saying that when you move terms across the equal signs, you have to flip the sign. Okay? So recall that, review the video on that if you need to. And the last 2 problems are pretty dang simple if you know what you're doing. If you don't, you're going to struggle with them. Basically, you want to prove, like in the first case, so this is problem 22, you want to prove that a plus b equals a plus c, then, so if A plus B equals A plus C, then B equals C. So you start with A plus B equals A plus C, and if only there was some way to get rid of the A's, and I can think of 6 or 7 ways to kill the A's, you have to come up with your own. All right? So maybe you might try moving this A across the parenthesis, the equality sign. You might try adding something to both sides. You'll have to figure it out. Okay? Same thing for problem 23. If you can do 22, 23 should be a cinch. These homework problems shouldn't take too long. 1 through 13 should stretch your mind and get you used to thinking logically with proofs and theorems. Otherwise, that's good. Anyway, guys, thanks for watching this video. I hope you enjoyed it. I hope you learned something new. Leave your comments below on what I can improve. Have a great day. Take care, and bye-bye. Hey guys, thanks for watching this video. This video is part of my series on Serge Lang's basic mathematics. You can click here to watch the rest of the videos in the playlist. You can click here to learn more about me, and you can click here to support my channel. Thank you so much. Bye-bye.